All right, so we are starting Module 3 today, and at the beginning of it here we are learning about properties of exponents and just understanding about polynomials, kind of just in a general sort of way. So these things are counted as a review because hopefully it's something that you have seen in other math classes, but you want to review over it. And if you feel like you need more help than what we do here on this video, make sure you check, go to the textbook and read through some of the examples there. You can watch videos that are on there. But another thing that I think is really helpful is I have some Desmos activities set up, and so I'm going to show you just a little bit about how to get into some of those. Let's see here. I can't remember. Let me... Okay, so I'm going to give you a little code here to help so you can do some of these activities and stuff. And so you'll see, like, when you go into the class that it does have, just different activities and stuff. And so the one I was thinking that you might want to go through, and these are all optional activities to do, but if you find that you're kind of struggling with some of those properties of exponents, this can be a really good one to go through. And I actually really like how it kind of does this, on here. And so I just have some of these activities that I've made, and yeah, these are ones I usually do in the classroom, but I just wanted to kind of show you a little bit of what they look like. So when you go in, you'll just click across and do these different slides and stuff that are here, and then they just kind of, go through, and basically on this one you're trying to, discover some of these properties of exponents, remember, what these properties are and stuff. So again, it's just some, another way that you can kind of learn about things, especially on these things that maybe you haven't had math for a while, so these properties of exponents aren't very, to the front of your brain, so if it's been a little while, then coming back and looking at some of these other things could be really helpful. So just keep that in mind as these activities. So I'm just going to write down on here. So for any of the Desmos activities that you do, let's see, so write this down somewhere, because if you go in and do any Desmos activities, then you're going to need this class code, which is NJTG8, and then Z. Right, so NJTGH8Z. And so if you put that in, then like I showed you, there will be kind of a list of activities there. And so the one that you would want to do for this is, it's called Discovering Properties of Exponents. But right now there's only 3 of them in there. Okay. So just a little bit of that so you can see, because as you go through these lecture notes, you're going to notice there's these Desmos activities. And so if you put in that code, you can kind of pick from those and do them. But let's talk a little bit about about these properties of exponents, because that's one of the things that we wanted to make sure that we go over today. So just some of the rules that there are. The product rule, you have, two of the same base, see both of these are A's, being multiplied together, but they have different exponents. And so when they have the same base, you can add those exponents together to get your answer. So you can kind of see some examples over here. If we had x to the 4th times x to the 3rd, we add those together to get x to the 7th. And sometimes it's nice, like on these, you can visualize them as well, like x to the 4th is x times x times x times x. And then x to the 3rd is x times x times x. And then if you count them all up, you'll see that there's 7 of them. So that's where that x to the 7th comes from. So if you're kind of a visual learner, then maybe writing things out to start off with can be a really good help. All right, but now the quotient rule, so if it's connected by division, then we subtract the exponents and make sure it's always the top exponent minus the bottom exponent, because remember with subtraction, that order matters. Okay, so top exponent minus bottom exponent. Then there's a power rule, so you'll have some parentheses and something all raised to a power. Well, that means that you're going to be multiplying these exponents together when you have a power raised to a power. So you can see over here, x to the 2nd, all raised to the 5th would be x to the 10th, because you're just multiplying those together. Okay, and then kind of similar to that is the power of a product rule. So notice that there's things inside this parenthesis that are being multiplied together, right? Then we can distribute that power of m, in this case, to everybody. All right, or there's also this power of a quotient. I'll skip down here so you can kind of see. If it's connected by division inside and you have a power on the outside, you can give everybody that exponent also. So this only works if it's connected by multiplication or division inside. If it said like a plus b or a minus b, we can't do that, distributing that through. Okay, but you can kind of see here, and this gets overlooked sometimes. So we have 2x all raised to the 3rd. Well, we're going to take 2 and raise it to the 3rd power. So sometimes that one gets overlooked. And then x and raise it to the 3rd power. And then just simplify it up. 2 times 2 times 2 is where we're getting 8 from. And then x to the 3rd. Okay. Another property that we need to understand too is just, and this sometimes people are like, yeah, it just seems kind of obvious, but if, when exponent is raised to the 1st power, it really, is just itself back. So kind of keep that in mind. Anything raised to the 0 power, though, is always 1. Okay, and I'm going to show you a little bit there, like how you can come up with that. Here in just a minute, I'll show you that. But notice here we have something crazy just written inside, all raised to the 0 power. Well, that's just going to be 1. Okay, anything to the 0 power is 1. And then the other exponent or property of exponent is with negative exponents. And so if it's raised to a negative exponent, we actually take the reciprocal of it, or we flip it, right? So we can think this is all over 1, and so that 1 goes to the top, and then we have a to the positive m on the bottom. So to change it from a negative exponent to a positive exponent, we've got to flip it, or take its reciprocal there. Okay, and same thing on that second one. Okay, so let me go back up here and just look at something with you. If I had something like x to the 5th divided by x to the 5th. All right, so if I think about this, I'm like, okay, well, I've got 5 x's being multiplied together on the top and 5 being multiplied together on the bottom. And when there's a, one factor on the top that's common with a factor on the bottom, we can actually divide those out, right? So x divided by x is 1. Anything divided by itself is 1. So we're making ones all in here. All right, and then 1 times 1 times 1 times 1 times 1 is 1. So that all simplifies to be 1. But if we look back to this, to the property that we had, oh, where did it go? Oh yeah, the quotient rule here. So if it's connected by division, then we subtract those. So if I tried using that on here, then I'd be doing x to the 5th power minus that 5th power on the bottom. All right, so that gives me x to the 0 power. So when I simplify it this way, I get x to the 0, but when I simplified it the other way, I got 1. So, and that's what's happening. That's why anything to the 0 power is 1, because we've got the same exponent on the top as on the bottom. Okay, so hopefully that kind of makes some sense to you, because that one oftentimes people will miss and forget that anything to the 0 power is 1. Okay, like I said, if you need a little bit more help with some of those, then make sure you go back and do that. We'll go through a few of these here, though, so we can see what to do. So on this one, since it's connected by multiplication, what do we need to do with our exponents? What are we going to do there if it's connected by multiply? Going to add them? Yeah, we're going to add them together. So 4 plus 10 gives me 14. All right, so y to the 14th would be your answer there. Okay, let's look at this next one, though, because it's kind of, something you need to pay attention to, because we have negative on the outside, 8 raised to the 0 power, plus negative 6, and that's on the inside of the parentheses, that negative raised to the 0 power. So on this first one, just 8 is being raised to the 0 power. And we said anything raised to the 0 power is 1. So I know that's 1, but I still need to use this negative out in front, which is kind of like a negative 1 that's being multiplied there. Right? So I've got negative 1 times 1 on this one, plus, and then negative 6 raised to the 0 power. Anything raised to a 0 power is 1, so I've got 1 here. So when I look at this, right, negative 1 times 1 is negative 1, and then plus that other 1 gives me 0 for my answer on this. On this one, when we're dividing, we subtract those exponents, so y to the 3 minus 2 power, right? Remember, you've got to do the top exponent minus the bottom exponent. And so that will leave me with y to the 1st, which is just y. So y would be our answer there. All right, now on D, we're getting, a little bit more here, a little bit more into what we need to do. So I might use some different colors just so it's kind of easier to see. So first thing we want to do is look at those coefficients. Remember, coefficients are those numbers out in front of the variables. And we want to look to see if we can reduce that. And I can see, yeah, if I divide, 2 into 8, I get 4, right? So 4 is remaining there. I'm going to just write so that 4 is going to stay on the top. Okay, but now let's look at our x's. All right, so I've got an x to the 7th and then a y to the 4th, an x to the 4th. And so since they're connected by division, I'm going to subtract those exponents. So when I subtract those, 7 minus 4, I get 3, and again, that's on the top. X to the 3rd is on the top. All right, now let's go to the next one, those y's. All right, and so with y, I've got y to the 13th over y to the 4th. Again, I'm going to subtract those and get y to the 9th. And then our last one's z to the 5th over z to the 4th. 5 minus 4 is 1. And so then I'm left with just a z on the top, a z to the 1st, or just z. And so I'm left with just a 1 on the bottom here, which I don't need to put. I can just say, yeah, this is my answer. Right? And so that's what you'd end up with there. Okay, looking over this one, here are some negative exponents. When I have negative exponents, I just like to flip them to where they're going to be happy. I'll show you the way, maybe the book does it and stuff, but then I'll show you the other way that I like to do it. So in this one, it's telling you, that you should do, if we're using that quotient rule like I was talking about before, we're going to take the top exponent minus the bottom exponent. So I'm doing -2 minus a -6. And this is usually the part where people make mistakes. It's just forgetting that you're doing minus a -6, which is really plus there, right? And so then I end up with x to the 4th. -2 plus 6 gives me 4, so x to the 4th. Okay, but if I look at it another way, like I said, I like to flip things to where they're going to be happy. So, if something is unhappy in the basement, maybe it wants to flip upstairs and it'll be happy. If it's unhappy upstairs, if it flips downstairs, it's going to be happy. So if I flip those, I end up with x to the 6th over x squared, because they're both negative, so I've got to flip both of them. And then I can see, now I'm going to do 6 minus 2, which gives me 4. So x to the 4th is still the answer. But like I said, it's usually this double negative, that minusing a -6, where people make a mistake. And they might say that's something like x to the -8 instead. But really it's x to the 4th. Okay. All right, on this one, we're distributing that power of 3 through to everybody. So let's do that. So I'll write it like this to start off with. So 2 to the 3rd power, and then I've got x squared, and I need to raise it to the 3rd power, right? Every single part needs to be raised to the 3rd power. Y to the 2nd is going to be raised to the 3rd power. And then on the bottom, I've got z to the 2nd, all raised to the 3rd power again. All right, and then if I simplify this, now be careful with 2 to the 3rd. A lot of times people accidentally put that as 6, but remember that's 2 times 2 times 2, so that's 8. And then since I have these parentheses here and I have a power raised to a power, this is where I need to multiply those together. So I get x to the 6th, y to the 6th, and then on the bottom I have z to the 6th. And I can't combine anything else together because I don't have any bases that are the same, right? If I had some x's on the bottom, then I could simplify them with those x's on the top. But I don't have that, so that is my answer. Okay, and then on this last one, I've got some negative exponents there, and so that's really kind of an important thing to notice here. Now, for me, I can see it's saying, all of this is going to be raised to -1 power. And so really what that means is I could flip all of that upstairs. So I'd have to leave what's inside there just like it is, right? But then I'm going to flip it upstairs. So I'm going to just put that here. So I've got 4x to the 6th power, y to the 1st, z to the -4. So I haven't done anything with this negative exponent. Remember, I was working with that one that was on the outside. And so since that was negative, I flipped everything upstairs. Okay? And now I can see that I have, this 3 on the outside that I need to distribute through to everybody. So let's do that next, where I'm distributing that through. All right, so 3 to the third power is 27. X to the first raised to the third is just going to be x to the third. Then y to the fourth raised to the third. It's power raised to a power, so it's multiplying, so y to the 12th. And then here I get z to the negative 9th power. All right, now I'll write the rest of this stuff out here. And then I just need to kind of combine things together that I have. I can see that both of my z's are negative, and so those guys want to go downstairs. So when I have my answer, I need to combine, the 27 times 4. All right, and sometimes it'll be on the bottom, and you'll want to just, see if you can reduce that fraction. But since both of these are on the top, we're going to want to multiply those together. And so that will give us 27 times 4 is 108. So I have 108. I'm going to combine my x's together, x to the third times x to the 6th. So I need to add those together, x to the 9th. My y's, there's an invisible 1 there, so I'm going to put that in there, y to the 12th times y to the 1st. Add those together, gives me y to the 13th. And then these guys are going to go downstairs, and then they'll be positive, and they're both z's, so I'd be able to add those together. So that means it's going to be all over z to the 13th. I can't tell if it's going to let me do this. So z to the 13th on the bottom. Nope, it won't let me. Hold on a second here. I'll write it like this. So all over z to the 13th. Okay, so now that all of that's on the top there, and just z to the 13th's on the bottom. Just ran out of space. Sorry about that. All right, so that's kind of our properties of exponents and what you need to understand about them. So there will be homework problems for you to work through, just making sure that you know how to use those properties of exponents. The other thing on 3.1 is we're going to talk about adding, subtracting, and multiplying polynomials. So to add or subtract polynomials, you've got to combine your like terms together is what you're going to be doing. So so combine like terms. And what I mean by like terms is the same variable with the same exponent on it. So this 2x squared and this x squared are like terms. But notice that the second one has an x in it, an x to the first, but there's no x to the first in this first one. So this 6x doesn't have anything to add with this, but it's still going to be part of our answer. And then I can see my -4 and -2. Those are also like terms. All right, so let's combine these together. So 2x squared plus, now there's like an invisible 1 here again, 1x to the second power. So I'm going to add those together and I'll get 3x to the second. So remember, those had to be the same in order to add them, so it stays that same like term when we put it in the answer here when we're adding and subtracting. Okay, and then we can see, all right, that plus 6x. Again, there wasn't anything to add with that one, but we need it as part of our answer. And then got our -4 minus 2, which would be -6. And so now I have all of those like terms put together, so that is my answer. Okay. Now with subtracting, I want you to be really, really careful, because this subtract is saying I'm subtracting everything that's inside here. So I'm subtracting a 3x squared. I'm subtracting a 2x. I'm subtracting a -4. So really what's happening here is I'm distributing a -1 through. So I'm going to show that on the next step because I want to make sure this is really clear. So this first one, that's going to stay the same. But then here, it's like we have a -1 that needs to be distributed through that second set of parentheses. So we kind of have like plus a -1 times our 3x squared plus 2x minus 4. All right, so let's distribute that negative through here. So when I do that, I end up with, well, all of these things stay the same here in the front. Write these out again. But when I distribute this, now I have a -3x squared. And -1 times 2x is -2x. -1 times -4 is +4. And now that after I've distributed that through, now I can combine those like terms together. So 2x squared minus 3x squared is going to give me just a -x squared. -4x minus 2x is going to give me -6x. And then the last one here would be 4 plus 4, which is 8, so plus 8. And now that would be my answer. Okay, any questions so far on what we're doing? I meant to ask you at the end of the properties of exponents. Is there something up there that you had a question on, or about combining like terms?
No, but this is being recorded, right?
Yes, it is.
Good.
Yep.
I know I'm going to go back. So far I'm good, but I know I'm going to go back when I start doing the homework.
Yeah, sounds good. Yep.
Thank you.
You're welcome. Okay, I'm going to skip problem 4 and problem 5, but I want to just reiterate here. I'd like you to go through these, but remember to take it, and it's like a -1 that's being distributed on both of those. So practice that, because that's usually the part where mistakes are made on it. Okay, so the other thing in 3.1 that we want to go over is about multiplying polynomials, but we need to first talk about the distributive property. All right, so you see something like this, a 3 on the outside, 2x minus 5 inside. We can distribute that 3 to both terms inside. So remember, terms are separated by add or subtract signs, so there's 2 terms in this. All right, and then this one on the outside just had 1 term. I was distributing through. All right, but if I do that, I'm multiplying those together, so I get 6x and then minus 15. So 3 times 2x gives me the 6x. 3 times -5 gives me the -15. And similarly here, just be careful if you have a negative number that you're distributing through, make sure you remember to distribute that negative to both as well. So here I'd have -5x and then -20. Right, so -5x minus 20 would be what we have there. Okay, so let's build on that idea here, and we're going to need to use some of those properties of exponents a little bit to be able to simplify some of this. So now we can see that we have a 3x on the outside. So 3x needs to be distributed to everybody. All right, so 3x times 2x is going to give me 6x squared. All right, so remember, and I'm going to just put these little invisible ones in here. Hopefully that will help you to see that, I'm multiplying those together, so I have to use that property of exponents that we said when we're multiplying, we add those exponents. So that's what I did there. All right, and then on the next one, 3x times 7 is just going to be 21x. All right, and then we can't combine any like terms together, so that would be our answer. Okay, let's do this. Now we're going to distribute negative 2x squared to everybody inside. All right, so if there's 2 things inside, distribute it to them. If there was 5 things inside, make sure you always distribute it to everybody. So here I get negative 10 x to the, now remember, we're adding those exponents together, so 2 plus 3 is 5. So that's going to be negative 10x to the 5th. Now let's distribute that negative 2x squared to 3x squared. Negative 2 times 3 is negative 6. X squared times x squared is x to the 4th. And then the last one, negative 2 times negative 2 is positive 4. And then x squared times x to the 1st is going to be x to the 3rd. You've got to add those exponents again together, and now that would be your answer. Okay, so make sure you know how to add, subtract, and multiply with these polynomials like this. Okay, and then the next thing that we're going to talk about here is, now notice I don't just have one number. So I had a monomial, that's what this is, it's one term, is being distributed to a binomial. There's 2 terms. And here I had a monomial, one term, that's being distributed to something that has 3 terms, or we call that a trinomial. Okay. And so that's what we were looking at here. That was just monomials that we were multiplying through. But on this one, we now have 2 binomials that we're multiplying together. And I'm going to show you a couple of different methods that you can use on this. And, you know, whatever way works best for your brain is what I want you to use. Always. So on this, right, notice that we have 4x plus 3 in one parenthesis, x minus 5 in the other parenthesis. So we're just going to be putting down each of the terms. So 4x, and that's a positive 3. Make sure you keep that sign, whatever sign is in front of there, with that number. And then here I've got x minus 5, so make sure I keep that as a negative 5. And now I'm just going to multiply these together to see what I get in these boxes. So 4x times x gives me 4x squared. 4x times negative 5 is negative 20x. 3 times x gives me 3x. And 3 times negative 5 gives me negative 15. All right, so I can see that I have these 4 terms now as part of my answer. So I'll write them down here. So 4x squared minus 20x plus 3x minus 15. So notice that these middle terms are like terms, so I need to combine those together. But the other 2 don't have any like terms to add with them, so those just come down how they are. So 4x squared, when I combine these together there in the middle, I get negative 17x, and then bring down that negative 15. Okay, and so that whole thing together is your answer. All right, so that negative there is becoming a subtract sign, and so is that one on it. Okay, and so again, like, you can choose to use this method, this box method that I just showed you here, or the other method is just the distributive property, which some of you may have heard of it called FOIL, right? Where FOIL stands for first, outside, inside, and last. And that's basically just telling you how to distribute this through. But really, we're taking that first term, right, and we're distributing it to both of the terms in the other one. So let's try this. So if I do 6 times 5, that gives me 30. And then 6 times negative x gives me negative 6x. And now I need to distribute. So I did the first in both of them. And then I did the outside terms. Now I'm going to do the inside term and the last term. So x times 5 is 5x, and x times a negative x is negative x squared. And then again, I can see that those middle terms I need to combine together. So 30 minus x squared be my answer. Now, if it asks you to write it in descending order, that means you need to start with the highest exponent, then the next highest, and the next highest. So if it wanted it written in descending order, it would be written as negative x squared, right? That negative, whatever that sign is in front of it, has to stay with it, minus x, and then this is a positive 30, so plus 30. Okay, so either way is correct. The only thing is on the homework, if it asks for it to be in descending order, make sure you write it like this. But both ways are completely acceptable. Okay. All right, now on this one, this problem 18 one, notice how it's saying 2x plus 7 all squared. And it's connected by addition inside. Remember I said if it was connected by multiplication or division inside, we could just distribute that power to both of them. But it's not. It's connected by addition. So what we need to do is it's saying 2x plus 7 times itself is what that squared means. So let's write it out that way. So 2x plus 7 times 2x plus 7. And then again, you can FOIL it, do the box method, whatever you want to do there. So 2x times 2x is 4x squared. 2x times 7 is positive 14x. Get another positive 14x there in the middle, and then 7 times 7 is 49. And then combine your like terms together. 4x squared plus 28x plus 49. And that would be your answer on that one. So do you see, if you were to try and distribute that power through to both of them, if you did 2x all squared, that does give you 4x squared. If you did 7 squared, you get that 49, but do you see you'd be missing that middle term? So that's why it's really important to make sure, write it out twice and just FOIL that through. And then this is really just the same idea that we've been doing before, right? We can't really use the FOIL acronym because we have 3 different terms here, but you're still taking that 2x, distributing it to everybody, and then taking that negative 3 and distributing it to everybody. Okay, so let's do that. It's really quick here. So 2x times 3x squared gives me 6x to the third. Remember to add those exponents together. 2x times negative 4x gives me negative 8x squared. Right? Because remember, there's invisible ones on these guys. Adding those together. And then 2x times 7 is going to give me plus 14x. Whoops, let's see. Hold on a second here. Yeah, okay, so sorry. Negative. Okay, so 2x times 7 is going to give me plus 14x. All right, and now I need to distribute that negative 3 through to everybody. And for me personally, I like to line up my like terms just so it's easier to combine them together. So when I do this negative 3 times 3x squared, that's going to give me negative 9x squared, right? So I'm lining up those x squared terms. Then negative 3 times negative 4x is positive 12x, because a negative times a negative gives me that positive. And then negative 3 times 7 gives me negative 21. And then I can just add these together. There's nothing to add with that one, so it comes down as the answer. Combine my x squared terms together, get negative 17x squared. combine my x terms together, I get plus 26x, and then bring down that minus 21. And so all of that would be your answer for that one. All right, any questions you can think of there? I know that, first one, it's kind of a long one because there's a lot to review in it, but if it's something that is familiar to you, then hopefully it's not going to take you very long to do. But if it's not familiar, make sure you go and figure out this stuff. It's so, so important to make sure you have down. All right, and there's just a little thing in here if you want to do. Again, these are just optional things, but a little bit of practice for you to multiply these together. And you're basically trying to see which way are you going. So you're starting here, which way are you going to go? And then try and make it all the way through the maze down there at the bottom. Okay. All right, but the other section that we need to talk about today is 3.2. And this one is a little bit different than what we were talking about in 3.1, but it's important to understand that what we're dealing with here are functions. Okay, and so I want to just try and, remind you about what we have done before. So if I have f of x equals 3x minus 4, and I'm asked to find f of 0, that's telling me to put 0 everywhere I see x. So I have 3 times 0 minus 4, and then 0 minus 4 gives me a negative 4. Okay? And when I do this, I'm actually finding a point that is on the graph. So I'm saying here x is 0, and then this really, that f of x is my y. So point on the graph is 0, negative 4. So I want to make sure that you see that. When you're doing this, you're really finding points on the graph, and that's going to become really important with what we're going to be doing in the remaining sections of this module. All right, we'll do just a couple more of these. Let's do one where we have some letters that we have to put in, because sometimes people are like, what? How do I do that? Well, you're going to take out your x here, and in place of it, we're going to put a negative x. So I'm going to have 3, and then times negative x minus 4. Well, 3 times negative x is just negative 3x, and then bring down that minus 4. I can't just get a number answer because I still have a variable there in what I'm plugging in. Here I could get a number answer because I just had a number that I was plugging in. Okay, but what about this part E? Sometimes that one kind of throws people off. But again, we're just plugging that in, right? This x plus 1 is going to go everywhere we see an x. So it was 3x. So in place of my x, I'm going to put x plus 1. And then I still have that minus 4 that I need to put there. So if I simplify this, I need to distribute that through, get 3x plus 3. And then minus 4, and I can combine those like terms to get 3x minus 1. And so that's what I'd end up with for my answer there. And this would be just the same kind of thing. Yeah, there's 2 variables, but you're still going to just kind of distribute it through like we did on this in this part E. Okay, so don't let those variables like trip you up or anything. Just know that it's still, we're trying to replace that. And you'll see, like, when you get to, like, calculus and stuff like that, you'll kind of see this a lot more, and you'll see kind of what we're talking about there. All right, and then similarly on this, all right, we're just, again, still, putting in things in place of it. So, I mean, I think on these first 2, you got a pretty good idea there, but let's look at part C. So on this one, I'm doing 3 over x plus 1. So again, in place of that x, I'm putting 2x plus 3. Okay, so kind of like when we did the substitution method before, all right, this is what x is, so I'm putting it in place of x on there. And then I still have that plus 1 on the bottom. All right, this was my x, and then plus 1 more. And so then if I simplify it, I get 3 on the top, 2x plus 4 on the bottom. And that would be my answer there. Okay, any questions so far just on this part where we're using that function notation to find different values there? Because we're going to build on that idea. All right, so the thing that you're going to see most in 3.2 is this thing called function arithmetic. So I could take two functions and I could add them together. I could subtract them. I could multiply them, or I could divide them. And so in this, we're just kind of working on here to see, like, okay, what happens when I add them together? What happens when I subtract? All right, and so on. So let's look at this, and I'll show you what we're going to do here. So this is just saying f of x equals 3x plus 4. My g of x is 2x minus 3. And so on this, it's asking me to find f plus g of x. So it's telling me to take that f function, and I'm going to add it to my g function. All right, so here was my f function, plus my g function is 2x minus 3. And now I just need to combine my like terms. So I get 5x, and then 4 minus 3 is a positive 1. So I get 5x plus 1. All right, what about if we subtract them? All right, so be careful on this one, because again, we're going to have our f function, so that 3x plus 4. But then I need to subtract, and you've got to put the next part in parentheses because I'm subtracting all of my g of x. So that 2x minus 3 needs to go in parentheses because I'm really distributing like a negative 1 through, like we talked about before. Okay, so let's see, when we do that, so that those first part stays the same, 3x plus 4. But when I distribute this, I get negative 2x plus 3. And now I'll combine my like terms together. 3x minus 2x is x. 4 plus 3 is 7. So equals x plus 7. All right, and then we can do the same thing with multiplication. All right, so we're multiplying those together. 3x plus 4 times 2x minus 3. So we're just going to be doing FOIL kind of there, like we talked about before, and then just getting those like terms combined together. So here, when I do this FOIL, I get 6x squared, and then minus 9x plus 8x, and then minus 12. And then I can combine those like terms together there in the middle. So 6x squared minus x minus 12. And that's what I'd be left with for my answers. Okay, and notice over here, this is important to know. So the domain on all of these that we've done so far is any real number. All right, so remember we talked about the domain of something where there is a fraction, right? And so you've got to be really careful if there's a fraction, because there could be an x value that it cannot be. So if this is my denominator, right, I have to take that to find the domain. I've got to take that and say that cannot equal 0, right? Because I can't divide by 0. And then I want to solve that for x so I can see what x can't be. So I've got 2x cannot be 3, and then divide both sides by 2. So x cannot be 3/2. It can be any other number, all right? And that's when it's in this form here, because when I write that out, I get 3x plus 4 on the top divided by 2x minus 3 on the bottom. All right, so x can be, and what this says right here, this is set builder notation. This is saying any x except x can't be 3/2. Okay. All right, and then now let's look at this and see, okay, so far we've just had, x's and stuff. We've added them, subtracted them, multiplied them, divided them, but now we have this number that we're trying to put in as well. All right, so there's a couple of different ways that you could do this. This f minus g of 4 is really saying f of 4 minus g of 4. So I could plug those in and subtract them and see what I come up with. All right, so let's do that. So if I put that in, again, I have my f was that 3x plus 4. So I'm going to do 3, and then in place of my x, I'm going to put 4. So 3 times 4 plus 4. And then minus, and again, I'm going to put this part in parentheses. I'm putting these brackets just to make sure it's really clear. Got to distribute that negative. But when I put the 4 into the g equation, I got 2 times 4 minus 8. Okay, and then if I simplify this, I get 12 plus 4. And then be careful in this because I've got to distribute that through, but I'm going to do one more thing here. Let's simplify this inside. 8 minus 8, but that's just going to give me 0 there. So I actually don't have to worry about distributing that negative. So when I do that, I just need to add these together and I get 16. So 16 would be my answer on that. What questions do you have on that one? I know that one's kind of a little bit different, but we're just kind of doing the same thing that we did up here, right? But now we just have two different functions that we're putting things in, numbers in. Still kind of the same idea. And then this one, we've got different numbers that we're putting into our f of x, but we still, so we're going to first start by doing, and notice that both of these are f equations. So most of them have like f and g, but be really careful and make sure you notice. So remember our f equation was that 3x plus 4. So I'm going to do f of negative 2. So if I put negative 2 in place of my x, I'll have 3 times negative 2 plus 4. And then I need to do minus all of f of 3. So again, I'm going to take the x out, put that 3 in parentheses next to it. Okay, and then let's just simplify this. So I multiply those together, I get negative 6 plus 4 minus, I've got to do this multiplication there first, so that's 9 plus 4. And then I still have these parentheses here that I need to get together, so that's 13. But I've got a negative I've got to distribute there, so that's going to be minus 13. And then when I keep going, right, just go from left to right, that's negative 2 minus 13, which is going to give me negative 15 for the answer. All right, please speak up if you have any questions, because if you have a question, somebody else probably also has that same question. All right, let's do just a couple of these together. Let's do B, and then let's do F. All right, we'll just do a couple of these so you can see. So this time we now have different functions, right? My f of x is x plus 5, and my g of x is negative 2x squared minus 3. So when I do this f minus g of x, taking my f equation, that x plus 5, and I'm subtracting off all of that negative 2x squared minus 3. So I had to put it in parentheses so I remember I've got to distribute that negative through to everybody. So I got x plus 5. When I distribute that through, I get plus 2x squared and then plus 3. And now I don't have a like term to combine with some of these, but they need to just come down as the answer. And usually we'll just put it in order from, like in descending order. So start with the highest exponent, so 2x squared. I don't have an x to combine with that one, but it needs to be part of my answer. But then my 5 and 3 can combine together to be 8. And so that's what I'll have for my answer there. Is that all right? You guys feeling okay about that? And then let's try and do that part F also. So let me write this down again. So we got f of x was x plus 5, and my g of x, so I don't have to keep scrolling back up, was negative 2x squared minus 3. Okay, so let's go ahead and do this. I guess I didn't even need my g of x, because again it's saying f of negative 2 minus f of 3. Right, so I'm just using this f of x equation. So again, when I put that in there, I've got negative 2 plus 5. And then I need to do minus, right, all of f of 3. So when I put 3 in there, 3 plus 5. So let's simplify what we've got here inside the parentheses, which is 8. So I've got minus 8. And then let's just combine those together. Get 3 minus 8. And that's going to give me negative 5 for my answer.
Do you think we could do D as well?
D?
Yeah.
Sure. Yeah, on this one, it's, I guess when you're doing the division, you're just putting the f on the top, so the x plus 5 goes on the top, and then the 2x squared plus 3 on the bottom. And then on this one, 2x squared plus 3, that can't equal 0. And we haven't really talked about yet how to do that. So I think on the homework problems, they won't give you something like that. They might give you just something that's linear. Because you'd have to take that 2x squared plus 3 and say that cannot equal 0. And so then I'd have, subtract that 3 over, I'd have to divide by 2, and then that x squared, I'd have to take the square root of it. So they're not going to ask something like that as far as like the domain goes, but if it just asks what would the function be, that's all you'd have to write. Yeah, there's nothing more that you can simplify on those divide ones. So those are actually the simplest, the nicest ones there. Okay, we're going to do just a couple more things here because on the homework, they'll give things to you like I've shown you here, but then they're also going to give you a table of values, and sometimes that kind of throws people off. So I want to make sure that you know how to do that. And then again, this is just kind of reminding you about domain like we talked about before. So let's look at a couple of these here. So if it's just asking you to find f of 9, remember this is saying when x is 9, what is y? So we're looking over here and we're looking at the f one, right? So be careful because this is g over here. So 9, so out comes a 2. All right, what about this one? What about f of 29? Well, f of 29 is 36. And then g of 14 is 70, and it's telling me to add these together. So on that, I get 106. Okay. And then just be careful to make sure you're watching whether it's subtraction, multiplication, division, and so on. So let's do one of these multiply ones also. So f of 29 was 36, like we said before. And then g of negative 8 gives me 41. All right, so I'm doing 36 times 41. Which is going to be a pretty big number there. All right. I've got negative 1,476. All right, but that's the only thing that you're doing there, right? Just kind of reading that chart instead. And then make sure you go over domain again. Went over it a bunch in the first few modules, so that's kind of a review there. But then on this one, we started doing some stuff with this in the first module as well, but I want to make sure it's clear to you what we're doing. All right, so f of 1, so it's saying when x is 1, what is y? So here's my x-axis. When x is 1, all right, and I look to see where it crosses there. Well, it crosses at y equals 1. So again, this is a point on that graph. Oops, 1, 1. Right? Isn't that the point right there? X is 1, y is 1. All right, but this one's saying when y equals 2, what is x? So again, I'm looking at my f of x function here, but this time I'm saying when y is 2, so that's here, where y is 2. Where does that cross the graph? Well, it crosses right there at 4. So x is 4. And so my point on that would be 4, 2. Right? Over 4 up 2 is a point on that graph. Okay. But let's look at let's do E. So this one's saying g of negative 1. So again, when x is negative 1 here on this one, it looks like my y, right? Because I'm thinking, where is it crossing? Here. It's crossing right there at 2. But then I need to add that to f of 4. Right? So when x is 4, y was 2. And so then I'll just have to add those two together to get 4 as your answer. So it's just kind of taking it a little bit further than we did last time. We talked about like this A through D part, but now it's just showing you, okay, I could, find different values on each of them and add those together. Okay? Or subtract them or multiply them or divide them like we've done. Okay? All right, and so then that brings us to 3.3, which we will talk about on Thursday. So, any questions on this? Algebra functions, these? I know, sometimes it's not until you start doing the homework, right? And then you're like, I think I've got it. And then like, oh, do I? So, yeah. So I'll get this recording up so you can rewatch it again or watch it for the first time for those of you that couldn't make it. And also, I was just saying that I'll get the exams corrected this week and I'll make sure that you guys know what you have there on the exam. And I'm hoping everything went well. I haven't even had a chance to look at any of yours yet. So, but yeah. All right. I'm going to go ahead and